So here you're given a table. Well, first, we're looking at a function, f of x. So we would label it as f of x and x. Next, let's see if there's a constant rate of change. Here, you're decreasing by 1, so you're adding -1, adding -1, adding -1 each time. On the other side, for the x values, you increase by 3 each time, and that's constant. So our common difference for x is 3. Our common difference for f of x is -1. So they have a common difference, so it is going to be linear, which means we can write it in the form f of x equals mx plus b. So first, let's find b. Well, this case, luckily, by looking at the graph, wherever x is 0, y, or f of x, is the b value. So the y-intercept, and we'll see this when we graph too, is -1. Now to find the slope, we use our formula, and we're going to pick any 2 points. So let's say some easier ones. 0, -1 will be my x1, y1, and 3, -2 will be my x2, y2. So y2 minus y1 over x2 minus x1. Keep, change, change. So -2 plus +1 is -1 over 3. So this is the slope. So we have f of x equals -1/3. It's a negative slope, so it's decreasing, x minus 1. So let's start by graphing this. Well, on the x values, I'm going to count by 3s, just to make it a little bit easier. So 3, 6, 9, 12, -3, -6, -9, -12. And then my f of x values, I'll just count by 1s. And then we're going to plot our points. So at -3, it's 0. At 0, it's -1. At 3, it's -2. At 6, it's -3. And at 9, it's -4. This is a linear function. Use a straight edge to connect it into a line. Label it as f of x equals -1/3 x minus 1. And notice that even if we didn't have the table, we were just given the function, the y-intercept tells us where to start, at -1. The -1 over 3 tells you your rise over run. So when the rise is -1 means you move down 1 and you go over 3. Now each space counts as 3 here, so down 1 over 3, plot a point. Down 1 over 3, plot a point. Down 1 over 3, plot a point. Now, in order to go in the other direction, you can change the signs. It's still the same fraction, but now it's going to be up 1, so from here, up 1, left 3. -3 moves to the left. So you can do it either way. Try on your own plotting these two tables on the coordinate plane. Your graph should look like this. So I have my purple dots are for this function, and my red dots are for this function. So we can see that they're two parabolas because they're both being squared. So I'm going to connect them into that U shape. Yours should be a little bit neater than this. And I'm going to label this one as f of x equals 3x squared. And the purple one, just because you won't be able to color code on the regions, we're going to label as f of x equals 1/3 x squared. Now, they should look symmetric. They should look even, straight U's. If you have the tables, then you don't need to label the points. That's extra. But you can see on my x-axis I counted by 2's. On my y-axis I counted by 2's. You can also see that when this coefficient is smaller, notice that the purple graph is wider than the red graph. So when the coefficient in front of the x squared is smaller, that makes it wider. When it's bigger, that makes it narrower. Again, copy down these two tables, the two equations, the two functions in this case, label f of x and x on your axes, and take a minute to pause the video and graph them on your own. So again, I have my points. I'm going to have this be my purple and this be my red. Now they're absolute values, so they're going to connect into a V shape. And again, I'm going to label as f of x equals absolute value of x minus 1, and f of x equals absolute value of x plus 1. So this is my f of x, and this is my x-axis. Notice in this case that when it's inside of the absolute value, minus 1 moves it to the right one, plus 1 moves it to the left one. So when it's inside the absolute value, minus moves it to the right, plus moves it to the left.